Suppose we try to find the area enclosed by one loop of the four-leaved rows given by R equals to cosine 2 theta. Very good. Going back to elementary calculus, graphing R equals to cosine 2 theta. Let's take a look at the shape here. So what are you going to have? You're going to have a four-leaved rows. And you're going to take one leaf and find the area, right? Okay, so let's just focus on one leaf here, because the question says just one loop. I'm going to take the loop crossing the very first and fourth quadrants. So what is my R? R is cosine 2 theta. This is my function. R is cosine 2 theta. So R is bounded between 0 and cosine 2 theta. Okay. Very good. So what about the angle? What's the angle like? What's the theta bounded between? When R is equal to 0, cosine 2 theta is 0. So 2 theta is inverse cosine of 0. 2 theta is equal to pi over 2. Theta is pi over 4. Take a look. Your theta is bounded between pi over 4 and also negative pi over 4. So these are the boundaries for my theta. Now use the polar coordinates to find the area. The area is equal to, here you have the double integral of your dA over region R, and region R is now converted into the polar coordinates. Theta ranges between negative pi over 4 to pi over 4, and R ranges between 0 to cosine 2 theta, R, dr, d theta. You automatically take dA and write R, dr, d theta. Very good. Now just let us compute this. Guys, for now, we cannot separate these two integrals because R depends on theta. Should be just careful here. This is equal to theta ranges between negative pi over 4 to pi over 4. And here you have a half R squared. R ranges between 0 to cosine 2 theta and then d theta. This guy becomes, well, you can take this a half, write it in front of the integral, negative pi over 4 to pi over 4, and this is your theta. And here you have cosine squared of 2 theta d theta. Here you have cosine squared. We have to reduce the power, otherwise it's going to be very difficult to take the integral. Recall that cosine squared of theta is equal to 1 plus cosine 2 theta divided by 2. or you can just use alpha to avoid any confusion with theta. So your alpha here is 2 theta. You need to multiply it by 2 as well. This guy becomes a half integral negative pi over 4 to pi over 4. And here you have 1 plus cosine of 4 theta divided by 2 d theta. So what do you get? You get 1/4. And here you have theta. And here you have plus 1/4 sine of 4 theta. And theta ranges between negative pi over 4 to pi over 4. This is equal to 1/4 and pi over 4. Sine of pi over 4 times 4 is going to be 0 minus theta, which is negative pi over 4, and another 0. So you have pi over 8 as the area of one loop. So you have the area of one loop.